Charles is going to talk a little bit about built-in macOS security tools and beyond. I know that because that's what it says on the slide. How many of you have ever heard Charles talk before? Okay. Well, the rest of you, we're going to take care of you now. So Charles has actually spoken at a number of MacTech conferences over the years and has done, it's been really fun to watch Charles be in this industry and go from 318 to Jamf and all the different things that you've been doing over the years on it. He's become quite the visionary on it. I mean, you actually, last year, laid out a bunch of stuff and I went, huh, that's kind of interesting to see how that's going to go. So I'm always interested to see what Charles has to say. But if you haven't had a chance to come up and meet Charles one-on-one and tell him a little bit about what you're doing and ask him a little bit about what he's doing, I encourage you to do so this week. You're going to be around this week. And so, no?
Yeah, I'll be here.
Okay, yeah. How about a warm welcome here for Charles Edge?
Thank you. I added and beyond to the end of this slide because in a few cases where I'm showing a tool, the way that you can do it with a little bit of third-party, open source, free, maybe inexpensive other tooling is often a little more gracious and user-friendly. So, so with that, why did I decide that I wanted to talk about Apple's built-in security tools? I sit at the confluence between Mac admins and Apple consultants and InfoSec teams a lot of times. I will spend, over the course of a normal week, maybe 4 to 6 hours on the phone with information security teams around the world, and they often want to know things like, what antivirus are you running? So just out of curiosity, who in the room is running an antivirus tool on their Mac right now? A little less than half for anyone watching the web view at the end. I didn't realize that was going to happen last year, or I would have done a better job with my presentation. Sorry about that. So the why. Apple has a lot of tools built in, and I find that there are two different camps when I'm talking to some of these companies. There's always the Apple administrator who's sitting there saying, but Apple has us covered, which is a long-term historical kind of view of this paradigm. And then you've got the information security team saying, we have a security posture. You have to install one of these 5 tools. In many cases, that's 5 different tools, all non-native, all potentially from other architectures. Almost none of them ever actually have a positive, or at least a real positive. Sometimes you have false positives. And the value of spending $80, $90, $200, $300 per Mac to put in deployment to run security tools on them is sometimes just not worth it. So why do we need security tools in the first place? Has anyone in the room used Metasploit? A few people. This is a list of all the Mac exploits in Metasploit. I should mention that Apple has patched every single one on this list, so none of them are active exploits. But if you happen to have a machine running 10.13.6 or something like that, then it might show up on one of these. And then the why. How do you like the build order of this slide? And then the why. What would an attacker potentially want? So Patrick did a great job of going through some of the exploits that are out there. Once a machine has been exploited, what is someone potentially looking for? Recently, I had a friend who called me and said that he was getting asked to reset his Apple ID once a day. And I was like, well, why are you getting asked to reset your Apple ID? Dig in, find a little piece of something running, and his Apple ID is sitting there in the clear in this property list, which we all have on our machines. And that, you know, the ability to then craft very specific attacks towards someone, if that's something that someone wants to do, all of these little information gathering things kind of help. Other things that an attacker might want, does anyone remember the good old days of Windows viruses where everyone in your address book got emailed an invitation to download that virus? That was them, not us. We never had that problem. Well, the information's there, and it's not very hard to exploit it. In the first line here, It's just show me all the addresses in my address book. And the second line is show me my browsing history. I added the second line because Patrick mentioned that in his presentation. So yes, I did update my presentation today. One thing about this presentation, I haven't made it all the way through without changing slides. Normally, I feel much more rehearsed when I can do that. In this case, I tried to include so many tools, and I forgot it was 50 minutes, that I never actually made it all the way through. Oh, and sorry, the first one was browsing history. The second one was download history. This is address books. So it's somewhat trivial to go into these SQLite databases and extract information. So what else are we going to cover now that we've looked at a couple of the why things? The first is threats. This is one slide just classifying the threats. The second is the Apple model, and that's where we'll focus mostly on built-in Apple tools. And then a little bit on sharing services and security scanning, which is where a lot more of the third-party stuff comes into play. So threat classification. One of the arguments that I've always gotten when I talk about security is that there's no viruses for the Mac. That's not exactly true. And according to how you look at it, if you say that, you're just being pedantic, and that makes me stabby. That is not a threat, to be clear, because threatening to stab someone in the state of California is a felony punishable by a minimum of 1 year and 1 day in jail. So I did not threaten to stab anyone, mostly. Okay, so malware, it's viruses, trojans, worms, and then the old school macro virus, which is pretty much what antivirus picked up for a solid decade of the Mac. And then I put keyloggers on here. And then in addition, there are vulnerabilities and various services that can be exploited and shared services. So the Apple model. I would say my favorite thing about the Apple model is that there's no real FUD. And if you listen to Patrick too much, you might think that there's no real security either. However, I definitely give them a lot more credit than I think a lot of security researchers do. I spent a few years speaking at Black Hat and DEF CON as well, and I would say in that time frame, I took a much more critical view towards Apple. I've helped write services there in the past, and I've become much more forgiving. Don't knock it till you try it kind of thing. Building operating systems is a very complicated task, and mistakes happen, especially when you have tens of thousands of developers trying to work in conjunction with one another, and you're moving into a more microservice-y type of architecture. So the first thing that we can talk about, I just realized there's confidence monitors. That changes everything. No. But anyways, is the T2 chip. I've often referred to this when I present as the iOSification of the Mac. Basically, by moving things into a secure enclave and starting to restrict what an app or a tool can access, we are making for a much more secure operating system environment. Things that go into the T2 can't be pulled out from the command line, things of that nature. Runtime protections. Most of the people in this room, unless you happen to be an actual Swift or Objective-C developer, don't care about this. The most important thing to know here is that one app can't invade another app's memory space unless it's been entitled to specifically do so. And these images, I just grabbed them from the Apple security website. So I'm going in the order of what Apple likes to tout when they're touting their security benefits. So FileVault 2, and this is where I want to switch and start going into under the hood of some of these things. So FileVault 2 encrypts your data. It's full disk encryption as opposed to the original FileVault 1. And under the hood, it's this FD setup command that can be used to enable, disable, add, remove, or get a status. If you see at the bottom, FDE setup status just says FileVault is on. That makes it really easy to report on the status of one of these machines. As was mentioned previously, if your security posture means that you need to full disk encrypt everything, this is a very easy thing to extract and report on. The other thing here, FileVault status can be managed by MDM profiles, and then keys can be redirected to either an HTTP or an MDM. And then Active Directory or Nomad can be used in conjunction with FileVault as well. So the next thing Apple likes to talk about are Safari extensions. The thing here is, over the years, this became an adware issue, so now all Safari extensions must be signed. I would say 90% of the time, when I get a phone call asking me to look at something, and I dig in, it's been a Safari extension, and that has been cut down dramatically since Apple made this change. Who else gets malware emailed to them about once a week? It's pretty sweet, isn't it? Yeah, that's all. Well, I don't write antivirus software yet. So anti-phishing protects you from fraudulent websites. Has anyone ever dug into this and look? You know how you go to a website and you get, or you get an email like this one, and I know that I don't pay for this. I don't know what this is, but there's this cute link, and when I click on the link, I get this nice bouncing skull on my. No, I don't really. So under the hood, what's happening here is it's using Google Safe Browsing, and this is a service that most browsers use at this point. And you can see when it was last updated. Going back to your security posture, this is one of those things that you might want to report on. But it effectively acts as an RBL service like the old mail server stuff. Now, one of the things that Apple doesn't talk about a lot, and I have a feeling this is because it upsets a lot of software developers, is rootless. So everyone's heard of system integrity protection. So that is part of an overall strategy called rootless. And if you look under the hood, suddenly we're locking down so that you can't change system user bin and sbin. Anyone ever used a tool called Tripwire? A few people. I don't talk about that in this presentation, but Tripwire is a host-based intrusion detection system that you could configure to email you or write out a log of any file that changed in a certain period of time. And it would basically go through, hash out the whole file system, and then if any hash changed between Tuesday and Wednesday, you could get an email telling you that something changed. Rootless, instead of telling you when something changed, just makes it where you can't change it. So also included with rootless are any apps that Apple provides. That's not exactly a rootless thing, that's more of a code signing thing. And under the hood, system integrity protection is accessed with the CSR util. There's only one command really, or one verb that works with this command right now, and that's status. If you run status, you'll see this, and my favorite is the last line. This is an unsupported configuration likely to break in the future and leave your machine in an unknown state. That is in no way concerning. I love writing errors, by the way. My errors are much worse. Since apparently I'm now Iron Man, I should start writing my errors to that effect. So some things can bypass these protections. The one that everyone's probably most accustomed to is just straight up disabling SIP. I've worked on large deployments of machines that stamp firmware on chips, things of that nature, and sometimes you just have to disable this stuff. But for the most part, I don't consider any machine with SIP disabled to actually be a production fleet machine in a large deployment. And most of us who write software now probably write software assuming that SIP is enabled. And then some kernel extensions can bypass SIP, and now we have user-approved kernel extensions. Has anyone done user-approved kernel extensions with an MDM? Do I just keep asking you to put your hands up? Everybody put your hands up. Thank you. Now I know you're awake. So certain profiles allow us to accept extensions on behalf of users via profiles. And then there are tools within the operating system that can show you what is running as a kext. Every keystroke logger I've seen has been a kext. Also, every antivirus tool, with the exception of maybe 2 that I've seen, run kexts as well. And this is one of those places where when the next major release of an OS drops, if that release hasn't been updated with everything that a kext needs, all of a sudden you could have crashy machines, and that makes end users stabby. By the way, that's not a threat that your users will stab you. That would be illegal as well. And then Kext Viewer I mentioned here. Mostly I mention it because I thought Patrick might be in the room. I don't see him, so I will de-mention it now. No, kidding. Okay, what does an app have access to? So there are a bunch of things in the system that can prevent an app from accessing just any old thing it wants. Gatekeeper, code signing, sandbox, and assessments. So Gatekeeper makes downloading apps from the internet safer. What that doesn't say is Gatekeeper makes everything on your machine that didn't come from the internet safer as well. So what does Gatekeeper look like? It's a simple system preference pane. There's only like 3 checkboxes and a radio button. Under the hood, though, code signing. Apps need to be signed for Gatekeeper to allow the app to open. So code sign is the command that can be used to both sign and evaluate apps and packages and disk images. And also, because Patrick's here, I mentioned what's your sign, although I think he mentioned it, which kind of makes it duplicative for me to do so. Sandboxing helps maintain or contain malicious code. So the thing about all of these technologies is Apple's basically saying our operating system is awesome, and the big concern that we have are all these apps that people keep installing, not through the App Store where we've evaluated them to make sure they're safe. So app sandboxing, and to put something in the App Store, you need to sandbox it. So app sandboxing, the ASCTL command can be used to evaluate what an app has access to. So if you're ever curious about, hey, what's this app got access to, that's how you do it. Other ways you can do that, there's a container check Ruby script out there. The cool thing about that is you can actually look at that Ruby script and see what Apple's doing under the hood and how they're evaluating this information. And another important thing about that is these are runtime things, so it's the active, it's how it's interpreted, all of these things, as opposed to just looking at the flat files to see what an app might have access to. And then sandbox exec. And you know, those prompts that we keep talking about with TCC entitlements, every time you click on one, you can reset those with the TCC util command. And that's pretty much the only thing that TCC util can be used for. Another thing Patrick mentioned in his presentation is when you get prompted with those buttons, you can't click on them with a script. You have to do that manually. Apple has some pretty sweet tech there to keep us from doing so. Obviously, there's a workaround for it right this second, but I doubt that'll last for long. So reporting. Many apps have a sandbox profile or a .sb file that you can use to see and or augment the rules being used. Based on the output of these, you can easily build a robust reporting framework. Should I just let you guys read the slides and leave? No? Oh well. And then as far as reporting goes, I include a Spotlight command here. So MDLS is a command that you can use to query Spotlight databases. And what I'm looking for here is the iTunes.app version. And the reason I put this command in here is because you can take this command and you can wrap it into a very little Python script. And what I'm doing here is I'm saying, hey, go out to the CVE database and report back to me all open CVEs for iTunes. And the reason I mention this is you could look at every single app installed on a Mac and do that exact same script and loop it through. In fact, I meant to do that, but then I got busy doing other stuff. So sorry, not sorry. So app notarization, this is something else Patrick mentioned, which I'm just going to keep saying over and over and over throughout this presentation. Obviously, I should have coordinated with him before coming. As a developer in Xcode, when you submit your app, you have the option to Apple. You have the option to have it notarized. If you're submitting it for the App Store, Apple's going to put it through their notary service no matter what you do. If you're building it to run it locally, you currently don't have to notarize your apps. In the future, I assume, and by assume I mean I know, that you'll be required to do notarization prior to being issued certificates from Apple. So this helps to solve a few different situations. Most notably, Apple really wants us to be very clear as developers about what we're going to do or what an app has access to when it's installed, what it's going to access. This was the same with iOS, and it's just further iOS-ification of the Mac. So next are those entitlement things. I mentioned TCC util, but you know, you can actually go in and you can view every container on the file system, and then you can see what an app's going to have access to. You can read container files just with a straight defaults command, and then when you're deploying software from a centralized location, you really don't want your users to get prompted 30 times when they're opening an app. And actually, there's not 30 things that it covers, but let's say 5. Because if you prompt them once, they might not call your service desk. If an app prompts them 5 times the first time they open it, they're probably going to call. And if you get 10,000 users calling your service desk, you're going to have service desk people getting stabby. Also not a threat. So when privacy preferences policies were first released, we went ahead and at my company wrote a, and by my company I mean someone else's company that I happen to work at. We went ahead and wrote a tool that allows you to build those manually. Oh, if you ever need it, the URL's in the presentation. There are a couple of other tools that do the same thing as well now. So as far as those apps and securing those apps goes, one of the things that keeps coming up is kind of Objective-C versus Swift. So everyone has tech debt, including Apple, and I would say Apple's tech debt is trying to migrate all their backend stuff into Swift from Objective-C. I don't know that that's entirely possible in the near-term future, so for all the Objective-C developers who haven't moved to Swift, you have a long runway on your career, I would bet. But Swift is the future, and one of the things about security is, about the differences between security is that runtime code compilation in Objective-C allows for method swizzling, and newer Swift apps do not. This is because all that's done at compile time as opposed to runtime. And then Swift doesn't use null pointers, but I mentioned here often when you're calling a framework that might use Objective-C, you might have to call one from Swift. So moving on, other built-in tools. The software update command is kind of the backend for the software update framework in Mac. You can use the version command to get what version you might be running of the operating system. And this is manageable and deferrable from an MDM. So if you're using some tools that don't work in the next OS release, you can always defer them for 90 days. What I'm seeing as a resounding effect of this is many security vendors are now taking the posture that they have 30 days to fix their stuff. So they're treating 0+1 or 0+30 as 0-day support. And that same CVE lookup, in case Patrick's been busy writing new exploits, this little snippet of code will look up any open CVEs for the version of Mac that a device is running. So you could use that or some kind of OS query type script to do something like that. I'm going to stop for 10 minutes so that you can all write this down. 11. I've got plenty of time, right? What time's this talk over? Whenever I'm done? In 6 minutes? All right. I can get through 45 slides in 6 minutes. On it. So security scanning, shared services. No, kidding. So really a shared service in my mind is any daemon opening a socket. There are some that you see in the system preference pane. And web sharing is gonna start Apache. And you can also wrap these in a very small script and look up CVEs for different versions. This becomes really interesting because in order to get a version of the Mac that passes a CVE scan for all shared services, you would have to recompile those services, therefore breaking the link between system preferences and the service, and probably rendering the service unusable. So I've been in a few different environments where we're trying to build a Mac OS deployment that meets all of the security requirements of a large team, and not been able to do so. So all of these services can also be disabled programmatically. The reason I mention this is because it ends up going into CIS guidelines. If you notice in this first thing with disabling the printer sharing, I'm actually disabling the sharing on each printer as opposed to disabling cups overall. You can also disable file shares in a very similar way where you just turn off each share. Some of these services don't necessarily have global controls, so when you're working with them from a central solution like VMware or a Jamf, you end up having to basically code around it. And those are just the things we see. Under the hood, there's a lot of things we don't see. If you run Netstat, it's a command that will show you all open network sockets. Then you can see what is listening on your machine by grepping for listen. And then you can do a whois against that in order to see more information about what's running and who's running it. LSOF is another tool that does something similar, although the thing I like about sudoing LSOF more is that I'm seeing what's running under all users' context, not just one. I threw a couple other examples of the LSOF command in here. Mostly, in my experience, when you're using LSOF, you're just constraining the amount of output you're getting and making it easier to find what you need. And I used an example here of rapport D. Does anyone know what the service does? So you know how when your phone rings, it rings on your Mac as well? This is the back-end service that does that link between those two things. And every now and then, you're using LSOF or some other tool like that, and you see these things pop up in the background, and you're like, what is that doing? So with rapport D, you can run strings against it or drop it into Hopper and see exactly what it's doing under the hood. But I don't trust things even if they come from Apple. Inherently, I like to know what's running on my systems just because I'm a nerd like that. Now, you don't actually have to learn how to use LSOF or Netstat or some of these other tools because there are tools on the market, whether they're free tools that you can download or paid-for tools that you can use to find all of this information. I mentioned Little Snitch here because Little Snitch takes almost all of these things that I've talked about up to this point and puts them in one pretty little GUI. So it shows me what port, it shows me who opened that port, why. It also shows me the code signature of that port so I can see who signed the ability to open it. And by code signature of that port, I mean the code signature of the daemon that opened the port. Who runs Little Snitch? Bunch of us. Oh, yeah, I should raise my hand since I asked. So snort is something else I mentioned. One thing Little Snitch is not going to show me, and this is, again, this is built-in Apple tools, but I ended up adding a few others. Snort, which you can install with one line from Homebrew, will show me what packets are going over that port as well. So I can inspect not only my own packets, but also sometimes other packets that are being sent. So for example, from my hotel room last night, I was able to grab a few things, but But let's see who's in the room on this. Fred Stinky, are you in the room? No? How about Kurt's MacBook Pro? Kurt, sweet. And that's nothing wrong. Our machines are just chatty, and they're going to put traffic out there, and you can listen to that traffic, no problem. So that's why it's so important to sign everything end to end in this modern era. It's not like it was when you could just telnet into port 25 of some SMTP server and stream an email message to it and not really care if everyone was listening to it. Back then, you had to have elite skills in order to intercept that traffic. And now, even people as dumb as me can. So what's where? Hypothetically, you open up. Little Snitch does a good job of telling you what a service is. They've got a database of those things. But at this point, you've got an open network socket. You find what services is opening it, and then how do you inspect what that service is doing and why it's there? So what's where? Activity monitor is obviously the first thing almost anyone learns to use on a Mac. That's going to tell you what daemon is there and some information about it. You can always get info on it and learn more. FS events is Apple's back-end way of showing us what is changing on the file system. So this becomes a way to see and track what's changing what. Task Explorer. Again, I guess the MVP of this morning is going to be Patrick. Enables us to see even more about those tasks. FS Monitor is another pretty GUI front end for FS events because FS Eventer is dead and gone. And then FileMon is another tool that I like to use for this. And I have very different reasons that I use some of them, but I would say the very first thing I normally do in this kind of context is I'll fire up Activity Monitor, see what's happening, how much memory something's using, where it was launched from, and then I might go into a tool like FileMon and look at what's changing on the file system. So then, what started that daemon or that service? So there's launch agents that run as user contexts and launch daemons that run as the system. And these are responsible for opening any process that runs on the system. So you can see what's running in the background with launchctl list or the nice GUI tool Lingon. The thing that I like about launchctl when I'm doing security research, as an example, is like a buddy called me and he had something running, and I was able to pinpoint what it was within about 2 minutes just by opening up launch control or launchctl, listing things, and you can just grep out for anything Apple and usually quickly find stuff. So, and then we already covered kexts, but kexts are another thing to inspect when there's something weird happening on a machine. So hosts, what might something that's been actually put on a machine be doing in the background or at once? And one thing that I've seen is in Etsy hosts, my rootkit box.mydomain.com. That wasn't the actual name of something that I found on machines. That would be a very bad name for malware. But if I were going to write something, I'd probably name it that because it would be like 4 in the morning and I'd be tired. And then hosts. In your etsyresolve.conf, I've seen things like mybotnetsdns.com. I did not see that exact entry in there. But these are 2 ways to redirect traffic to make it easier to do things like man-in-the-middle attacks. And as an example, I wrote a quick extension attribute the day that Mamie was released for Jamf Pro servers. You could easily take this and run it in any other tool. It's not a Jamf specific thing, but basically I just looked for the entry in the hosts file and flagged it as infected or not infected that way. So other things, logs. That's probably where we spend most of our time. And console is cool, but you can get a lot more. I personally like to do a lot of this at the command line because I can use various commands. Apple has a new logging framework, newish, I guess. And on my website, there's an article on how to kind of quickly find things in there. It would take me half an hour to talk about. And you're all ready to sleep already, I hope, because lunch was good, right? Was lunch good? You have to say that, or Neil will not feed you tomorrow. So better logging analysis. The first third-party tool that I mentioned here is kind of the ELK stack. The thing I really like about this is it's super fast, and then with the Logstash integration, it can take logs from lots of different things. And I was at a customer one time before I left the consulting world, and there was, how when you have 2 or 3 different symptoms that maybe have the same root cause, or maybe you have 3 different causes for a single symptom, those kind of issues can take days, if not weeks, especially if they're not always happening. I can sift through Logstash in minutes and triangulate issues. I also mentioned Splunk. Splunk is really cheap if you don't have that many logs, and then it's really expensive if you do. I love Splunk, but I can't afford it personally. So, and then visualization. There's lots of tools out there like Domo, BrightGauge, and they can help you to visualize some of this stuff, because just seeing lots of logs and lots of entries, if you put that in a chart, sometimes you can very quickly figure out things that you couldn't have figured out otherwise. Or at least that's the way my brain works. So let's go back to malware. True or false, the first virus was on a Mac? I only asked that so I could have a chance to get something to drink. So then the era of macroviruses, and that was a solid 10 years where we as Apple users could pass viruses to other people, but we couldn't actually get them ourselves for the most part. Yeah. And that kind of died down when all of a sudden Word asked you to enable macros or disable macros. Sorry? Oh. So Patrick has been kind enough to post 97 samples of malware on his website. I would strongly recommend taking all of them and opening them on your favorite antivirus tool and seeing what it catches. I can say I did this across 20 different antivirus tools, and not a single tool caught more than 80%, including Apple's built-in stuff. So, and then I mentioned Safari extensions in here. Even though it's getting better, I still see things out in the wild, sometimes because people haven't updated and sometimes because they have. Who tweeted a picture of me? Thanks. Watches are great. So, no security through obscurity here. Obviously, I'm right here. Although I'm going to go shave, and then none of you will recognize me. So antivirus options. There's a full list up on Wikipedia. This does not include any that I have written. And then there's XProtect, which is built in, and that really is meant to protect against things when they're coming in. And MRT, as Patrick mentioned. The thing I like about MRT is that you can use your own custom Yara files, so you can build your own files. If you, for example, open all of those things and scan them from Patrick's website and some aren't caught, you can grab a signature and add them to the built-in Yara file. Well, you can't edit the built-in Yara file, but you can call MRT with a custom Yara URL and then URI, and then you can watch them get caught and see what Apple does to them. The important differentiation here is MRT is kind of necessary because things can get in. It's not like Gatekeeper scans every possible way to get into a Mac. If you think about it, you can airdrop files to one another. You can download files off the internet. You can download files off of shares. You can download zips and extract them. There's just a lot of different ways that files get on a Mac. And then I mentioned ClamAV. Oddly enough, ClamAV, the free open source tool, was the tool that caught the most viruses in my testing. And then I mentioned scanning at the gateway because whether it's email or a firewall, you can also catch things there. So MRT. This is a very basic incantation of the MRT command. Sudo system library core services MRT app contents macOS MRT-A. That was not a mouthful. And you don't have to take pictures of the slides because Neil said they're available. But you're welcome to. I don't care. So definition files, as I mentioned, are in an open standard format. I'm a big fan of open standard formats, no matter where I work. Come on, Greg. That was for you. And a third-party GUI. So ClamAV, you can install it very easily via Homebrew. You edit one comp file, and then you can do manual scanning pretty easily and set up automated scanning. There used to be a package for this, but when I was prepping the presentation, I couldn't find it. And then there was also ClamXAV, which I also couldn't get running anymore. But the nice thing about ClamAV is it's plug-inable. So it's designed to be run as a manual scan tool, but you can build plugins that, for example, hook it into Mail or other tools. So other than viruses, I'm going to have to start going quicker, so apologies if you can't understand any of the words I say. But, whoops, going backwards is not going to help me go quicker. Common criteria tools, all the logs. Common criteria is a set of standards such that every single action that you do on the machine can be tracked. Audit D is the daemon that common criteria would run as. And then audit reduce allows you to filter out all the unnecessary entries. When you enable the common criteria tools, you'll suddenly start getting just gobs and gobs of logs. You can use the PR audit command to view these, and they're in var audit. Has anyone used common criteria or any of the PR audit stuff? Ed, you just get to leave your hand down because I'll assume yes, because they're termed security researchers in your title now, I think. So what's connected to the machine? Not only what are people doing, but what physical devices have been connected to machines. I've been in some environments where they don't allow external hard drives, as an example, or where display monitors aren't allowed. So IO-Reg allows you to see that stuff, and then System Profiler from there. Keychains, security, the command can be used to create certificates, view certificates, create keychains, view keychains, all that fun stuff. You can also dump keychains. And then you can interface with keychains both not only using security through bash, but also through Swift. And profiles, a common attack vector that I hear from some people is they want to use an MDM solely so that other people can install profiles on machines because they see that specifically as a threat. I would prefer to think that people use tools I write, like MDMs, for better reasons than that, but whatever. One thing about MDMs, UAMDM was introduced to force users to explicitly allow the installation of profiles, and this is for non-supervised devices. So if you're using an MDM and the users are not joining that MDM via DEP, then they'll get prompted to accept it upon installation. So what's on your device? Profiles list all. That'll show your profiles. And then you can easily remove them unless they've been marked as non-removable, because you can mark profiles as non-removable. Once upon a time, you could go into the profiles directory and delete them, and reboot, and the changes that were made by the profile would be undone, but at this point that's now protected by SIP, and you can't do that anymore. So penetration testing. Anyone who is into security, this is the fun part, right? Ed? Yes. I paid him to say that. So I mentioned Metasploit earlier, so we'll just look at a quick installation basic use of Metasploit. So Metasploit is a framework for running basically a playbook that will exploit a machine. When you install Metasploit, you'll get an MSF console command. You can use that, and then these commands will specifically, in sequence, allow you to load an exploit and run it on a client. Here I'm running it against myself. You'd never do that in the real world. And then exploit. So set payload. That's where I'm adding which of the Metasploit payloads or scripty attacks can be run. And then I set the host name, I set the port, and then run exploit, and it will try to attack the machine. You can see a list of all available payloads with the MSF Venom command. And then from there, you can fire them up in the console. I think I wrote this slide before the last one, but that's okay. So what does a payload look like? Here you'll see a bunch of stuff that gets shoved into a buffer. And so you're basically setting the settings and then shoving this information in there. I don't think we have time, but I think it would be a really interesting talk to go through how one of these exploit works with shoving stuff into a buffer. Earlier, the word fuzzing was used as a term. I once left a machine running for 3 months with a fuzzer trying to exploit or DOS a Mac, and after about 3 months, I finally accidentally rebooted it and decided not to start over. But basically, what you're doing with a lot of those tools is you're just saying, okay, this is what you'd normally shove into this, and I'm going to craft randomly generated characters and try to put that in there as well. So more on payload generation, offensive-security.com, URL's there. Disassembling software. Anyone use Hopper that's not named Ed or Thomas or Greg Nagel? I use Hopper to usually, I would say the main thing I use Hopper for is when Apple introduces a new binary onto my system, I use Hopper to see what verbs I might be able to use when I'm calling it. I might also extract other software with it as well. Network scanning. So basic port scanning, there's a command called stroke on your machine. It works. There's a command called ARP on your machine. Has anyone ever set up a switch that requires you to ARP poison in order to set the switch up? That is the dumbest thing I've ever seen, and it still works. But that's aside from the point. Service interrogation, often, if you telnet into port 25 of a mail server, you'll see it'll have a banner that tells you what that is, or port 80 of a web server. And then I mentioned Nmap, which is easy to install. Used to, some of this stuff was hard, and we deserved to make more money. Now, Homebrew and GUIs have ruined it for everyone. But when you run an Nmap scan, such as this one, you can actually get the version that's running, so OpenSSH, and that, again, you can look up in CVEs and try to find ways to attack systems. And then that version of OpenSSH, here's a bunch of CVEs for it. And then Google Santa, who that doesn't work or hasn't formerly worked at Google has used Santa? A few people. I'm really a fan of this kind of dynamic binary whitelisting and blacklisting. And then there's CIS guidelines for the Mac. To me, this is one of the most important things. You can spend as much time as you want securing systems, an unlimited amount of time practically. The thing that's nice about CIS guidelines or any of these types of guidelines is that it puts us all on the same page about what security means and what security posture means to us. And then people in organizations can choose which of these things that they want to turn on their systems. But at least people are making that choice and understanding the security ramifications from not choosing that. Stethoscope. This is a new tool. I think it's like 3 days old or something. But it allows you to, on your Mac, get a cute little report of how that machine is, how that machine meets to a given security posture. So in summary, check OS and app versions against known CVEs. I may or may not be working on a larger framework to do this in the future. Customize CIS scripts to suit your security posture. Know what ports are listening on hosts and also what binaries called them and who signed them. And then use an MDM or scan for profile installations and play with Metasploit and have fun, because really trying to exploit things is the fun part of security research. And also trying to sleuth out why someone built something a way that they built it. So that's it. Thank you. And there's some links.